So I'm Rachael, a microbiology student at UWA, and I'm here along with my fellow students, Tendai, Anthony and Callum, to explain everything there is to know about the Hepatitis B vaccine. So, let's jump in. Hepatitis is a disease of the liver, and it can be caused by the contagious hepatitis B virus known as HBV. This results in serious acute liver inflammation, and if left untreated, leads to chronic cirrhosis and can actually lead to about 80% of all liver cancers. It is transmitted through bodily fluids, so any sexual contact or needle sharing with a HBV positive person has an 80% chance of infection, so it's important to be tested. Also, perinatal transmission from a HBV positive mother to a child has a 70% chance of infection, so anyone, regardless of age, can contract HBV. But some people are at a higher risk, such as native inhabitants, intravenous drug users, people who have renal failure or have a previous liver disease, and those who are immunocompromised. Since the first case of HBV in Australia in 1965, the development of the HBV vaccine in 1981 has provided people of any age immunity. Infants, children, and adults can be given a 3-dose vaccine cycle, where the second dose is given after 1 month and the third dose is given after 6 months. The adult dosage is a 1 milliliter vial containing 20 micrograms of recombinant hepatitis B surface antigen. And for children, a 0.5 milliliter vial containing between 5 and 10 micrograms. But the type of vaccine is important, isn't it, Tendai?
That's right, Rach. Hepatitis B is a subunit vaccine containing hepatitis B surface antigen produced by recombinant DNA technology from yeast cells. After purification, the hepatitis B surface antigen protein is absorbed onto elemental aluminium as hydroxide or phosphate. It is considered to be safe and highly effective. The vaccines are available either as monovalent formulations or in combination with other vaccine antigens. The monovalent recombination types are NGRX-B and HBV-VAX2, which is manufactured by different processes and delivered intramuscularly in infants. When immunizing against HBV at birth, only monovalent hepatitis B vaccines should be used. The other antigens found in combination vaccines are currently not approved for use at birth. The combination vaccines such as Hexacin and Twinrix Jr. 360/10 include an inactivated hepatitis B along with other inactivated variants such as poliovirus, hepatitis A, and many others, and can be delivered to anyone older than 6 months. So, I'm going to leave it to Anthony to tell us about the immunobiology of the hepatitis B vaccine.
A hepatitis B vaccine may seem like a simple cure to prevent future infection, but our bodies go through a lot of complex work in order to create immunological memory. Following introduction of HBV into the body, the antigen is recognized by professional antigen-presenting cells, such as macrophages and dendritic cells, which migrate to the nearest lymph node. It then presents the HBV antigen to naive B and T cells. Activated B and T follicular helper cells interact in the follicles of the thymus. The activated B cells then undergo rounds of selection and mutation for high affinity mutants that result in high affinity antibody secreting plasma cells and memory B cells. Antibody producing plasma cells and memory cells can be quickly reactivated following secondary recognition of the same antigen. In vaccines, chemicals called adjuvants are added to induce the normal inflammatory effects from the innate immune response in the presence of infection. This stimulation upregulates the adaptive immune response. The two main adjuvants are aluminium hydroxide and aluminium phosphate. Aluminium adjuvants work by directly stimulating monocytes to produce pro-inflammatory cytokines activating T cells. Activated Th2 cells release interleukin-4, which in turn can induce an increase in the expression of MHC class II molecules on monocytes. The increased expression of antigen-presenting and co-stimulatory molecules leads to the enhanced accessory functions of monocytes. I will now pass you on to Callum, who will discuss the importance of vaccination and the impact of vaccination programs.
Vaccinations made an enormous impact on our global health system, essentially eradicating diseases such as smallpox and rinderpest. Following the development of the HBV vaccine, which gained FDA approval in 1981, 75% of the global population have received the vaccination, yielding an 80% success rate, resulting in the prevention of clinical hepatitis. The HBV vaccine has been successful in demonstrating herd immunity following its integration into the National Vaccination Program by the World Health Organization. The principle of herd immunity is that when someone is vaccinated, not only are they protected from future infection, but they are unable to transmit the disease to others. This protects the immunocompromised people in our population. Virus spread virtually stops when the immunized percentage of people reaches a certain critical threshold. This is virus and population specific. Currently worldwide, there are more than 2 billion people infected with HBV, 360 million of those being chronically affected. Acute and chronic HBV are serious problems in Australia. In 2016, it was estimated that 230,000 people are living with chronic HBV. This represents about 1% of the population. Outcomes of HBV infection are largely age-dependent. Persons with chronic HBV infection have a 15 to 25% chance of dying prematurely due to HBV-related illnesses. Alright guys, that brings us to the end of our vlog about HBV. I hope you learned something and I hope you guys stay safe. Remember to subscribe.